Hello and welcome to our presentation about libclcxx, which is C++ libraries for OpenCL. My name is Ole Marius Strohm and I'm joined by Ishfaq Wardag. So to begin with, I will talk about the motivation behind libclcxx and the initial exploration of using libcxx in C++ for OpenCL. Then Ishfaq will go on to talk about the creation of libclcxx and finish off with the summary and future work. So C++ for OpenCL is a relatively new kernel language that brings C++ features to accelerators that support the OpenCL standard. However, it currently doesn't bring with it the C++ standard library. And this isn't ideal because a lot of C++ features are added through libraries. In fact, about 70% of the specification pertains to the standard library, and libclcxx aims to rectify this. So to begin with, I started exploring the various libraries in libcxx and trying to use them in C++ for OpenCL without any modifications at all. However, C++ has a lot of features that C++ for OpenCL cannot support, for example, function pointers or virtual functions, because these cause diverging execution, which isn't easy to map onto the OpenCL model. There are also a few other features that are unsupported. C++ for OpenCL also has address spaces, which define where memory is stored, either close to the current working unit or globally. And since libcxx is written in C++ without address spaces, these will all have to be deduced by the compiler. So after looking through a lot of the libraries in libcxx, I decided that type traits was the most promising. This is because it is compile time, which means that unsupported features such as function pointers and such are not an issue because they disappear at compile time. It is also header only, which makes it easy to use and deploy, and it has no dependencies, which makes it a good starting point for this exploration. It is also a library with many useful utilities and features a lot of metaprogramming, which makes it a good test of the address space deduction in relation to templates. So trying to use type traits in C++ for OpenCL wasn't without its own issues. I did have to fix two issues in Clang, one related to template variable address space deduction, and another one which was a simple missing address space in the default copy constructor. We also added two extensions to allow for using unsupported features such as function pointers, but only temporarily while including type traits. So this is not an issue because since it only allows it in type traits, which is compile time, these features are never going to be used on the GPU itself. For testing type traits, I wanted to reuse the existing libcxx tests. About half these tests work without any modification at all, and the rest were modified with a script that removed common things like structs with virtual functions or test invocations with function pointers, and other unsupported features. However, this doesn't change the test coverage because it only removes things that a user of libcxx C++ for OpenCL could not use anyway. However, since I wasn't doing any modifications of the library or test currently, I did not add any OpenCL-specific tests, which means that I wasn't testing OpenCL types in the type traits functionality. And in the end, about 88% of the tests ran as expected, and the rest are actually unsupported. So of the 18 failing tests, 8 of them depended on other libraries in libcxx. 7 of them used C++20 features, and the other 3 were unsupported type traits functionality, such as has virtual destructor, which is unsupported because you can't have a virtual destructor in C++ for OpenCL anyway. And now on to Ishfaq, who will talk about libclcxx.
Thank you, Ole. Okay, what is libclcxx? It is a new GitHub project to contain C++ libraries usable for OpenCL. libcxx can't be used straight away right now, and for that, to rectify that, we need to use some clang extensions, as Ole mentioned earlier. Firstly, we worked on integrating libcxx and other dependencies into the new repository using Git subrepo. We then added automated building and testing using CMake and documented all of the work done using Doxygen. Overall, the main objective of this project was to open a new repository as a framework for new development. Now, the first library we worked on was a type trait library. So we added an include directory for library header files, and then the first header file we opened was the OpenCL type trace header file. And this was to port the standard type trace library. As you can see here, as Ole mentioned earlier, we need to enable function pointers and a periodic function clang extensions, and then include type traits from libcxx and then disable these straight away. And these won't affect any code execution at runtime, as this is only compile time. And then after that, we tested exhaustively all the libcxx type traits library with OpenCL-specific features. We did this using static asserts, and then we worked on fixing any failing cases. So we did that by specializing a template for the failing case with the correct behavior. After that, we added some custom type traits for OpenCL-specific types. These include vectors, address spaces, images, and the half precision flow. On the right here, you can see an example of a custom type trait we added, which is the remove address space type trait. And this resembles the standard implementation of type traits. And as you can see, there's a default case where we just have a type that's the same as the type passed in. But in specialized cases where the type passed in has a predefined address space, we just remove the address space and then have a type member variable without the predefined address space. Here's an example of use where we transform data from a buffer into a vector. So first we include the type trace library, and then inside of a kernel, we make use of an OpenCL-specific type trait that remove address space type trait, which I just described earlier. And then we also make use of a standard C++ type trait, the remove pointer type trait. And on top of that, we also make use of another custom type trait, the vector_in type trait, in which you pass in a type and also a integer size, and then it has a member variable, which is a vector of the specified type and size. And here we convert data from raw memory into a vector using the following generic helper function. And the main benefit of doing this is that it can perform some computations much more efficiently using the pre-mentioned vector_n type trait. And then once you can compile this code, and when you pass in these parameters into the arguments into the command line, you can get out a 4-element vector using the first argument, and the second argument will get you a 8-element vector of char. Here is some helper code to help execute that example correctly. So in summary, the existing implementation of C++ libraries, libcxx, has been explored, and now we have a public open source repository available on GitHub, and this has been created to host the C++ libraries for OpenCL project. And libcxx implementation is being reused for OpenCL to partially inherit functionality from C++. And the first library we worked on was a type trait library, and right now it contains all C++ type traits as well as some OpenCL type traits. Regarding future work, we need to do more testing and bug fixing. We are inviting anyone interested to experiment with the library, and any feedback would be greatly appreciated. In the future, more libraries can be contributed by anyone. These could be ported from the standard C++ library, or they could be newly developed. And an open challenge is how do we stay in sync with libcxx? On top of that, we would like to avoid in-tree modifications as they're costly to maintain, and we need to maximize the collaboration between libcxx and libclcxx developers. Another question we ask is, can changes required for OpenCL be added straight into libcxx? Thanks to these other contributors who helped with this project, including Pedro, Marco, and Stuart from ARM. And we hope we have garnered some interest in this project, and we encourage everyone to have a look at this project, and thank you for giving us your time.